During Mechanics 1, you're going to do a lot about suvat equations, and you're going to use them quite a lot throughout the course. Now, suvat is a way of finding the various bits of information about a particle. S, its displacement; U, its initial velocity; V, its final velocity; A, its acceleration; and T, its time. Now, we're going to look at 5 different equations to do with suvat, and 3 of them are on this slide, and unfortunately you need to learn these equations as they're not given to you in an exam. So, it says displacements, velocities and accelerations have directions as well as sizes or magnitudes. You can derive the formula for motion in a straight line with constant acceleration. Now, acceleration is the change in velocity divided by the change in time. Okay, so the acceleration, if we use the letters we've just looked at, A is equal to V minus U divided by T. And if you rearrange that a little bit, you get V is equal to U plus AT. Now here, we've already got 2 of our suvat equations. This one here, and this one here. They're 2 of the suvat equations. Okay, and we can also find the distance moved. Now you should know from GCSE that using this little triangle, distance is equal to speed times time. Okay, so the average speed is equal to U plus V divided by 2. And if you rearrange that, you get S is equal to, in brackets, U plus V divided by 2 all times by T. And that is our 3rd suvat equation we've got to know. We'll look at 2 more on another video. Right, now we need to obviously practice using these. Now it's very important throughout the course that whenever there's a question like this, you draw a diagram. Now if we look at the example diagram above, we're going to use that to help draw a diagram for this question. Now remember what I said from earlier on, you need to make sure you highlight all key things through a question. So I'll read it and then I'll go through and highlight the key points. A particle is moving in a straight line from A to B with constant acceleration 3 meters per second to the minus 2. Its speed at A is 2 meters per second to the minus 1, and it takes 8 seconds to move from A to B. Find A, the speed of the particle at B, and B, find the distance from A to B. Now, a couple of things. Let's draw down a diagram, but let's firstly identify the key points. So, it's moving at a constant acceleration of 3 meters per second to the minus 2, and its initial speed at A is 2 meters per second to the minus 1, and it takes 8 seconds to get to B. So, our diagram, our first part is here. This is point A, and this is S distance apart. So, and there's our particle at B. Okay, and at the start we're told its initial speed in that direction, velocity sorry, is 2 meters per second to the minus 1, and at the end we don't know, so that's a question mark. But we also know the acceleration. Notice now that acceleration's got 2 arrows rather than 1. 3 meters per second to the minus 2. Now there's one other thing I've not put on this diagram, and that's the time it's at B. Well, we're told that at T equals 8. Now, it's also very handy to write out a list of key facts like this. So, suvat, so write that down, suvat. So write in what we know. Okay, so we know the initial speed is 2 meters per second to the minus 1. We know the time is equal to 8 seconds. And we know the acceleration is 3 meters per second to the minus 2. Now in the first part, part A, we're asked to find the speed. So we're trying to find V, which means we don't need anything to do with S. So put a cross next to S. So if we try to find the final velocity, or final speed in this case, just look at this equation. V equals U plus AT. So write that down. V equals U plus AT. Write in what we know. So V, that's what we're trying to find, is equal to 2 plus our acceleration, which is 3 times 8. 3 times 8. 3 times 8 is 24, so 2 plus 24. So our new velocity is actually equal to 26 meters per second to the minus 1. Right, for part B, we're now asked to find the displacement. So let's write another set of suvat out. So suvat so this time we're trying to find the distance. We know the initial speed is 2. We know the final velocity now is 26. We know the acceleration is 3. And we know the time is 8 seconds. Now, we're going to use the second equation, the third equation given to here. S equals U plus V divided by 2 all times by T. So, let's write down that equation. So, S equals, in brackets, U plus V divided by 2 all times by T. Now, in this equation, we don't need the acceleration, so we can actually just cross that one out. So, let's plug in what we know. So, S, that's what we're trying to find, is 2 plus. So, let's put in what we know. So, S equals 2 plus 26 divided by 2 times by 8. So, the bracket becomes 2 add 26 is 28, divided by 2 is 14, so we want to do 14 times 8, and that will give us our distance between A and B. So 14 times 8 is 112 meters.